The power wheel is a visual representation of Ohm's law and the power equation. It relates voltage, current, resistance, and power to one another. It shows how all the variables involved can be rearranged mathematically to calculate the others based on the information you have available to you. When analyzing a simple DC series circuit, there are three variables one is usually concerned with: voltage, current, and resistance. These three variables are related to one another mathematically via Ohm's law. The discovery of the relationship between current, voltage, and resistance was credited to George Simon Ohm. Ohm was a German physicist who determined that current through a series circuit is directly proportional to the applied voltage and inversely proportional to the resistance of the circuit. Mathematically, this is shown in the equation current equals voltage divided by resistance, or I equals V over R. The Ohm's law triangle is used as a memory aid for remembering how the variables can be algebraically rearranged in the Ohm's law equation. Simply cover up the variable you want to find with your finger, and the equation will be apparent. So let's talk about the variables in Ohm's law. First is voltage. Electromotive force is commonly created mechanically through the use of magnetic fields or chemically through batteries. We measure electromotive force in units of volts. A fully charged battery cell produces around 1.5 volts, but cells can be added together to provide higher voltages if needed. Next, let's talk about resistance. Resistance is a characteristic of every component involved with electricity. Even the wire used to connect components in an electric circuit has resistance. Many components, such as the wiring, have very low resistances and therefore are ignored when we calculate with Ohm's law. Resistance is measured in ohms. Resistors are components in an electrical circuit that are designed to intentionally oppose current flow. They come in many shapes and sizes and are made using a variety of materials for different purposes and have a wide range of values. Lastly, we'll mention current flow. Current is the flow of electrical charge between points of different electrical potentials, voltages. Current's measured in amperes. Current flow is what makes things happen in an electrical circuit or machine. Because of this, it's important that we're able to accurately calculate and/or measure the current flow when we're analyzing electrical equipment. Now that we've been introduced to the variables in Ohm's law, let's get back to the Ohm's law triangle. If we put our finger over voltage, we can see that voltage equals current times resistance. Covering current, current equals voltage divided by resistance. And covering resistance, resistance will equal voltage divided by current. So we can now calculate how much current is flowing through a resistor, which is specifically designed to oppose that flow, much like faucet valves oppose the flow of water into your sink. But how does it oppose that current flow? What happens is that a resistor will convert some of that electrical energy into heat. This is known as power consumption, and it too can be related to the variables from Ohm's law. You may have noticed that the light bulbs you purchase for your lamps are rated based on wattage. This is power consumption of the bulb. Power is rated in watts. What's happening in your bulbs is that the voltage from your outlet is providing current flow through the filament, which is acting as a resistor in the circuit. When the current passes through the filament, it gets hot and it begins to glow. Power consumption can be calculated as power equals current squared times resistance, or I squared R. Similar to the Ohm's law triangle, the power wheel shows all the possible equations for each of the variables between power, current, voltage, and resistance. Electricians and engineers often use the power wheel, or something like it, as a reference when designing or testing electrical circuits and equipment. Thank you for watching my brief introduction to Ohm's law and the power wheel. I hope you found the topic as interesting as I do. Goodbye.